Hello students, how are you all? I hope you all are studying, and one gentle reminder that download our app Nakhyatra and the link is available in the description box. There you can interact with me directly to do the live classes, clearing your doubts, and even online tests are also available. There is another good thing about the app is that you can even watch the recorded classes. Well, let's start the lesson number 8 of your electricity chapter. The cartoon is funny, right? But it is definitely not funny to touch any open wires with your bare hands. Otherwise, you know the result, I guess. Okay, the effects of electric current. The first effect is the heating effect, and the second is the magnetic effect. The third effect is the chemical effect. So, we will first discuss about the heating effect. So, now see here, these are the few examples of electrical appliances which works on heating effect of electrical current. The first one is the television, the second is the iron, and the third one is the electric bulb. So this is a conductor where atoms in the state of vibration and the free electrons in the state of random motion. You can see here. These are in the random motion. Now we connect it with a circuit, and we can see that since the electrons are moving within the conductor, it creates kinetic energy. And the kinetic energy is converted into heat energy. So see here how it is converted into heat energy. Because we know that according to the law of conservation of energy, energy can neither be created nor destroyed. It only can be converted into one form to another. So here the kinetic energy is converted into the heat energy. Is that clear? Okay. So this is a scientist Joule. Now according to the Joule's law, so when electric current is flowing through a conductor, heat energy is produced. Now heat produced in a resistor is directly proportional to the square of the current, the resistance of the conductor R, and the time for which the current flows. So see here, this is the first circuit where current is flowing and the charge is Q in time t. Now from Coulomb's law, I equal to Q by T. So Q equal to I into T and mark it as equation 1. Now see from the second circuit, the current I is flowing and the resistance here R, and the potential difference is your V. So according to Ohm's law, we know that V equal to IR, marked it as equation 2. Then from the third circuit, we can see that the charge Q is flowing, and when charge is flowing, the work has been done, and the potential difference is V. So V equal to W by K. Rearrange it, and W equal to work done equal to V into Q, marked it as equation 3. Now substitute equation 1 and 2 in equation 3. After substituting, we will get W equal to IR into IT. Therefore, W equal to I square into R into T, and Joule. Okay, don't forget to write the unit. For work done, the SI unit is Joule. Therefore, this one is your heat energy H. H equal to I square into R into T. The unit is same, Joule. Okay.
कोई भी सपना साकार करने के लिए सबसे जरूरी है सही कोच का होना। चुनिए नख्यात्रा को और करे अपनी 4th to 12th classes and government preparation का सपना साकार। Download the app now.
Next is electric bulb. It is the most common thing you can see. So it is a small and simple light source that uses a wire filament to glow on the application of electricity. The filament, which is a coiled thin wire, is made of a material called tungsten. It has high resistance and high melting point, around 3380 degrees Celsius. Now see, the bulbs are filled with chemically inactive nitrogen or argon gas. Why you know? Because it prevents the oxidation of tungsten filament used in the bulb. Am I clear? Okay, next we will see the applications of heating effect of electric current, and we will take an example of electric iron. So see here, in an electric iron, the down portion here, it has a coil which has high resistance, and it is covered by an insulated mica sheet. And that insulated mica sheet is a bad conductor of electricity, but it is a good conductor of heat, because it prevents the current from entering into the metal and thus protecting the user from getting an electric shock. Okay. So the down portion here is your heavy metal block. Okay. Now when electric current passes through the coil, it gets heated. This portion, this coil gets heated when electric current passes through it. So we can say that an electric iron is based upon the principle of heating effect of current. So this principle states that when an electric current is passed through a conductor, it generates heat because of the resistances present in it. Okay, the resistance converts the electrical energy into heat energy. Next is electric fuse. Now what is an electric fuse? An electric fuse protects circuits and appliances by stopping the flow of excess current. So see, it is basically a safety device that operates to provide protection against the flow of current in an electrical circuit. So this is an electric fuse, you can see, and the down portion is the porcelain body. So it has a wire which is made up of lead and tin, and it has low melting point. Now see, when the main supply is connected through an electric fuse to an electrical appliance, here we are taking the TV as an electrical appliance. Okay. So see, domestic voltage in our house is around 220 volt to around 240 volt. And when there is a supply of a 230 volt to any electrical appliance through the fuse, there is no harm in the electrical appliance. Now see the term short circuit. We are very familiar with this, right? So it means very large amount of current flows. So when a large amount of current flows, we can see that when there is no electric fuse, the TV or any electrical appliance will break down. But see, what is the role of electric fuse? So any high voltage is coming, so we can see that the important component of an electrical fuse, that is the metal wire that melts when excess current flows through it. So it helps to protect the device by stopping or interrupting the current. Am I clear to you? Okay, so the fuses used for domestic purposes are stated as 1A, 2A, 3A, 4A, 5A, 10A, etc. Now let's do some questions. Why are coils of electric toasters and electric irons made of an alloy rather than a pure metal? Or the question can be asked as, nichrome wire is used for making the heating elements of electrical appliances like iron, geyser, etc. Give reasons. Okay, so see the answer. Coils of electric toasters and irons are made of alloys rather than pure metals because first point is resistivity of alloy is higher than pure metals. So see, pure metals have lower resistivity than alloys. Second point is alloys have higher melting point and so they don't melt easily. So the alloys which have high melting points and they don't melt easily. That's why the coils of electric toasters and irons are made of alloys rather than pure metals, because pure metals has lower melting points comparatively to alloys. Third one is alloys do not oxidize at higher temperature and thus can be kept red hot. Okay, now the last question. Why does the cord of an electric heater not glow while the heating element does? See the answer now. The heating element is made of alloy which has very high resistance. So when current flows through the element, it becomes very hot and glows. Okay, now see the heating element which is made of alloy. Now alloy has very high resistance. So the current flows through the element, it will become very hot and then it will glow. because of high resistance, and when current flows it becomes hot and then it glows. Okay. Second is the cord is usually made of materials like copper and so has low resistance. Thus, for the same current, the cord does not become so hot and hence does not close. Now, are you clear? See here, the materials like copper, it has low resistance. So, the materials which have low resistance, and if the same amount of current is passing through, then the cord does not become hot and hence it will not glow. Okay, so students, this is all about today's lecture. Hope you found it useful, and do not forget to share the link among your friends. Okay then, thank you.